Thank you for joining me for part 2 of our Spirometer video series. In this video, we'll focus on using the built-in tools of SparkView software to analyze data related to changes in lung volume. In part 1, I collected data under two conditions: normal breathing and maximum inhalation followed by forced exhalation. We'll use that data to find tidal volume, vital capacity, and forced expiratory volume in 1 second. Let's revisit the graph of lung volume versus time from part 1. For the first 35 seconds or so, you can see on the graph data was collected, but there was no change in lung volume. During this time, I was not breathing through the spirometer mouthpiece. To get a better view of the data I'm interested in, I'm going to slide the graph over and stretch the x-axis. Now you can see I have a much better view of the data that shows those changes in lung volume. When I began breathing through the mouthpiece, I took 4 normal breaths, trying to inhale and exhale as I normally would. Following these 4 normal breaths, you can see a more dramatic change in lung volume. We'll analyze that in a little while. Let's first analyze the normal breaths. From this data, we can obtain a value called tidal volume. This is the amount of air moved into and out of the lungs when breathing normally. I'm going to use a tool that selects a region of data for analysis. I'm going to open up my Graph Tools palette. I'm going to use what we call the Select tool. With the Select tool, I can select a specific point and see the coordinates of the point. But remember, in this case, I'm interested in a region. So I'm going to turn on the Select tool, and I'm going to select the ends of the region I'm interested in. So I just did a click at the data points, again, that are at the beginning and end of that region of interest, and you can see that it highlighted that region selected in yellow. I have more tools in my graph palette here that I can use to analyze this region. I'm going to use the Coordinates tool. When I apply the Coordinates tool, you'll see it gives me the x1 and y1 and x2 and y2, but importantly it gives me the difference in y. So lung volume, being my value on the y-axis, is the change that I'm interested in. So my difference in y is 0.78, and that's 0.78 liters as the volume of air that was moved into my lungs during that time of inhalation that I've selected on the graph. I'm going to go ahead and preserve that value for future reference. I can also choose the T tool here, the annotate, and I can type in tidal volume and the value 0.78 liters. Since I've now preserved that value for future reference, I'm going to turn off the Coordinates tool. I can move tidal volume over. And now I can turn off the Select tool so that I'm then able to select another region of the graph. The 0.78 liters, that is the amount of air moved through the lungs or in and out of the lungs during normal breathing, is much less than a person's lung capacity. To determine another value called vital capacity, we'll need to analyze the change in volume when a person exhales forcefully after taking a deep breath. For this measurement, we'll analyze data that corresponds to the person exhaling as much air as possible out of their lungs. I'm going to move my graph over a little more. So in the center of the graph, you'll now see that maximum breathing effort from the data I collected in part 1. So I took a deep breath and then forcefully exhaled as much air as I could out of my lungs. I'm going to use the Select tool again to highlight the region of interest. And if I don't select exactly what I'm interested in for, you can see I kind of missed the peak of the line there. I can use the corners of the selection area to be sure that I select what I'm interested in. And I can click OK. So you can see that I've selected the maximum exhalation, emptying the lungs again of as much air as I possibly could. Applying the Coordinates tools to that, I see the difference in y, or the change in lung volume, was 2.49 liters. As I did before, I'll annotate the graph so I can preserve this value for future reference. Now, vital capacity isn't total lung capacity. There will always be some residual volume of air in the lungs, but this corresponds to the capacity of a person's lungs for the maximum amount of air that they can move through their lungs with a deep inhale and forced exhale. Lastly, let's use the graph to find what we call FEV1, or forced expiratory volume in 1 second. I'm going to turn off my selection tool so I can then select a new area. In this case, I'm interested in data that's specific to the first second of exhalation. So I'm going to adjust my graph again a little bit more. Kind of stretch out that area where I was exhaling with maximum effort. So you can see from the graph that it was just after 49 seconds that I began that forced exhale. I'm going to use my select tool to, in this case, select a single data point instead of a region. So I'm going to select around the time where I began to exhale. I can adjust that data point that I'm interested in by toggling right or left with the orange arrows. So I began to exhale right around 49.3 seconds, and you can see that the lung volume was 3.98 during that. Now I'm going to select a data point 1 second after that. I want to see the change in volume for the first second of exhaling. So I'm going to turn off my selection tool and then select just after 50 seconds. So again, I want 50.3, so it matches the first data point of 49.3. It's just 1 second later. So again, I toggled back and forth just using the right and left arrows, and I can see that the lung volume here now is 2.16. Comparing this lung volume to the lung volume 1 second prior of 3.98 liters, I can see a change in lung volume was 1.82 in that first second of exhalation. So again, I'm going to annotate my graph. I can select the point on the graph that I want to annotate. And in this case, I'm going to call this FEV1. So the vital capacity corresponds to the maximum amount of air I was able to forcefully remove from my lungs, whereas FEV1 refers to the amount of air, or the change in lung volume, occurring in the first second of exhalation. Often a ratio of FEV1 to that forced vital capacity is used to evaluate a person's lung health. I can use my auto scale button to return to the graph that will show the best view of my data. And from here I can close my graph tools and manually adjust the graph to show the values of interest: tidal volume, vital capacity, and forced expiratory volume in 1 second. Once you're familiar with obtaining these values from the data you acquired with the spirometer, you can explore further to test if age, gender, or exercise affects the lung volume measurements. This ends part 2 of the Spirometer video series. We welcome your questions and feedback at learning@pasco.com. My name is Cynthia Sargent, and I thank you for joining me today.